Good morning, everybody. I was just saying thank you to Joanna. I'm absolutely not the most important person in the room. I'll come on to thank Lynn in due course. It's a real pleasure to be with you. I always think of this as a really important conference for the university each year. And this is a highlight, of course, each year. Certainly it has been for myself, the 3-minute thesis competition. And very shortly, I'll be introducing you to our 3 judges today and asking them to say a few words about themselves, and then we'll come on to our 6 presenters. Just before I do that though, let me say how nice it is to join the conference and to be able to salute your theme of the transition to net zero in the north of England. We all know this is a hugely urgent issue, and that there's going to be gathering public and I think especially student interest in this and your 4 key sub-themes as we approach COP26 in Glasgow in November. And the sub-themes I'm referring to are, of course, about what we can learn about climate excursions in the climate record that will help us decarbonise, the role of geoscience in delivering net zero, minerals and materials for delivering net zero, and what we can deliver to COP26 and what we can take from COP26. As ever, this is a flagship event for the university because it brings university academics and students, importantly, together with colleagues from industry, third sector, and the public policy world. And I hope and trust that you're finding it as enjoyable as ever, even if we are, unfortunately, for a while longer still, I suppose, online. I'm delighted that the Durham Energy Institute is working so closely with the North of England Institute of Mining and Mechanical Engineers, both at conference and to deliver net zero. And as ever, and as Joanna has just said, I and all of us are indebted to Lynn Gibson and the team for organising the conference. So let me now introduce your judges, the 3 of them, for the 3-minute thesis competition, and we'll get underway with our 6 presenters. Our 3 judges will be marking the presentations out of 10 in terms of 3 main indicators, just so that you know if you're not a judge. Comprehension, which includes the research question and results. Engagement, which is beautifully phrased in my notes as will the audience want to know more, and communication. That's the clarity of the presentation, the timing. Do try and keep to 3 minutes, everybody, and stage presence. So I'll introduce our judges in alphabetical order, starting from the university's Department of History. We have Dr. Adrian Green, who's also a DEI fellow. So Adrian, if you could say a few words about yourself, please.
Thanks very much. My nephew is amazed that I'm a historian of chimneys and the chimney tax. He's astonished how much interest I take in 17th century chimneys in England or Croatia for that matter. But it does make me a historian of energy use, particularly in the Northeast region, because I study the takeoff of the coal industry and its impact on housing, and my interests extend to England more generally and English America.
Brilliant. Thanks very much, Adrian. Very nice to meet you. That is an interesting topic, clearly, for a large number of people. From the Department of Earth Sciences next, we have Professor Chris Greenwell, who also has an attachment to the North of England Institute of Mining and Mechanical Engineers. Chris, can I go over to you, please?
Thank you very much, Stuart. Good morning, just about everybody, I think. And yes, I'm a professor in geochemistry in the Department of Earth Sciences, and also pleased to be able to sit on the committee of the North East Institute of Mining and Mechanical Engineers, and I'm also a fellow of that institution as well. My interest in energy go back a long, long way. I grew up around the South Wales coalfields, and my grandmother's brother was the chairman of the Hugh Valley Borough Mining Association. And I have worked on a variety of energy applications, including biofuels, including public engagement in biofuels around the UK, as well as working with some of our local companies looking at wind energy and other alternative energy sources. Thank you, Stuart.
Great, thanks, Chris. And then from our Department of Geography, we have Dr. Sarah Nuth, who is also a DEI fellow. So Sarah, if you could say a few words, please.
Hi, yeah, I'm Sarah Knuth. I'm from the Department of Geography, as Stuart said. I'm an economic geographer, although I'm originally from the US, as you can hear. I'm from another very deep energy region from Western Pennsylvania. So lots of coal and oil history and fracking now there as well. So my research looks at a lot of different angles of the green economy and just climate change transition, including a lot of work in California on new geographies of renewable energy development and financing. Really excited to hear everybody's presentation today, so thanks.
Thank you, Sarah. Really good to meet you. I'm so sorry I got your name wrong there. Forgive me. I think, like many of us, we've got so much personal history invested here. My paternal grandfather was a coal miner in the Derbyshire coal fields, so that transition to the coal economy that Adrian and others have been working on really, I think, is of great interest to many of us. So we have our three judges, and after we've had the presentations, the judges are going to take a while, obviously, to listen to what they've heard, and they will go away and come back at 4:15 to deliver the results. In fact, they'll be delivered, I think, by Barbara Vest. But I think we're ready now, Lynn, if our presenters are ready to go to the 3-minute presentations. Good. So our first presenter is Michelle Uriate. If I've got your name right there, Michelle, forgive me if I haven't. And as soon as you're ready, I'll invite you to get going. I can see that your presentation has been loaded, and it's very nice to meet you. So as soon as you're ready, Michelle, off you go.
Oh, great. Okay. Zero waste. You probably have heard about this concept a lot in the last couple of years. And this is mainly because a lot of countries have tried to implement this model, but it seems that every country is doing it in a different way. For example, in Mexico, where I am from, this means mainly focusing on recycling or waste to energy. Zero waste movement normally promise consumers that if they do their fair bit, like recycling or separating the waste, or even bringing your own mug to Starbucks, that you can save the planet. But is this true? You see, the main problem we have with waste nowadays is that we see it as something that can be managed, something that can be hidden, something that can be burned, something that is just out of place. We also see it as a result of an ever-growing population, and we tend to see consumers as lazy, novelty seekers, or unethical. So I wanted to see if that was the truth. I did my research in Mexico City, and I mainly focused on 3 materials: bottled water, clothing, and mobiles. I found out in Mexico City that actually the myth of novelty seekers was not true. One of the main reasons people change phones in Mexico City is because the last one was stolen. Actually, holding your phone for a long time in Mexico City is reserved for a few privileged. In the case of bottled water, I found out that people were not feeling guilty for buying this product because they were told that they were recyclable. But recyclable and recycled is completely different. And only 20% of the bottles in Mexico City get recycled. And nowadays, we're the #1 country who consumes the most bottled waters in the planet. In the case of clothing, we seem to be really quick to be judgmental against people who buy at fast fashion stores, but that's the stores that people can normally afford to buy things. So what's actually worse? Judging a low-income family because they buy at these stores, or judging the company that allowed a system to sell £2 shirts. You see, individual change is all really nice and sounds amazing, but it's never going to be enough to create substantial change. We have been fueled this narrative by the companies and the government. They have placed the responsibility on our shoulders. And I think it's time for us to shift that narrative and make those companies and government accountable for their unsustainable practices. It is only through this realization that we can actually dream of a zero waste society. Thank you.
Thank you, Michelle. That's absolutely on time. Very, very well done. I think I saw at the bottom of your screen. Are you working with Mike Krang then?
Yes, I am.
I know Mike very well. So excellent. Thank you. We're just going to be loading up the next presentation, if that's right, Lynn. Aidan, are you ready?
Yeah, ready to go.
So as soon as you like, and good luck with your 3 minutes.
Brilliant. Hi, thank you. So yeah, I'm Aidan. I'm a PhD student at Durham University, and my research is looking at understanding and improving aerodynamic performance of wind turbines, specifically that have been affected by leading edge erosion. So why am I looking towards this topic? So offshore wind is obviously a rapidly growing market at the minute, and it's instrumental towards the drive for green energy, especially in places like the UK, where there's a large abundance of shallow coastal waters. So this is seen through the installed capacity of offshore wind increasing up to 10.5 gigawatts in the UK at the start of 2020, which is enough to power over 20 million homes. And then because of this, the levelized cost of energy, or the price that the operators will sell the energy at, it's also decreased rapidly, and now approximately 2/3 the cost of electricity produced by gas turbines, so it's very competitive. But erosion presents a big barrier towards this continued growth because of developed from high velocity impacts of particulates such as rain. There's large costs associated with that. So first, there's a reduction in aerodynamic efficiency, which reduces the power output, and also blades need to be repaired and replaced, which means there's downtime of the turbines. So my research is looking at two methods. So firstly, there's this computational side, which has a high versatility and the ability to conduct a wide range of simulations and different inputs. And also a large amount of data comes out to be analysed to help understand why the changes are occurring. And then on the opposite side, there's an experimental approach, which has the ability to analyse physical specimens and measured levels of erosion in order to tune and validate the CFD model in the future. So an example of some of the results that have come out already have the power curves up at the top right there, which is from simulation data. And that kind of shows the power output of a wind turbine over its operating wind speeds. And you can see there's this small difference between the clean and rough case here, and that generally correlates in an established erosion case like this to approximately 1% reduction in the annual energy production, which when considered with the profit margin of an operator of maybe around about 18%, would correlate to actually a 5.5% loss in overall profits, or for a single 8 megawatt wind turbine, that would be almost £500,000 lost over its lifetime, which is very significant. Therefore, I've worked with my project sponsors, who are Erst and Siemens Gamesa, who are both leaders in their respective fields, to help develop the deliverables that we've got up here, which I'm working towards, to help maintain a profitable and more competitive market for offshore wind. Thank you.
Thank you very much, Aidan. Bang on time as well. Thank you very much indeed. Another excellent presentation, really interesting. We're going to load up our third presentation then. I see some comments coming in as well in chat. Those of you that got chat on. Best of luck to all competitors, says Andrew. We've got Chris Challen. Chris, are you there? Yeah.
Hello. Yes, I am.
Hi. When we get going, Chris, if you just quickly introduce yourself and your department, and then we'll run the 3 minutes after that. It's not the introduction. Have you got your presentation?
My name is Chris Challen. I'm from the University of Sussex down in Brighton, and I'm in the engineering and design department of that university, specifically electrical power systems. So maybe a little bit different from some of the other topics that have been discussed at this conference. So I'm really grateful to have been invited along to this and given the chance to present my work.
Yeah, well, we're delighted that you're with us, Chris. Thank you for introducing yourself and telling us where you're from. Are you set to go?
Yes, I am.
So good luck, and start as soon as you're ready.
Thank you. Modern electrical power transmission networks are designed to be resilient against the disconnection of the single largest generator in the network. This is known as N-1 resilience and should prevent any disconnection of consumer load. Electrical cascades can, however, occur in rare circumstances, such as the UK lightning strike in August of 2019, which caused multiple transmission lines to fail, disconnecting a number of generators and leading to an electrical blackout which affected 500,000 consumers. Existing research primarily focuses on preemptive measures, such as identifying and reinforcing weak areas within the network in order to increase resilience against cascades. My research studies whether intervention actions can be taken instead in the middle of a cascade in an attempt to limit the impact for consumers. I approach this problem by considering parallels between the way cascades spread through an electrical network and the way biological viruses spread through a network of people. They are both triggered by a small number of individuals. They both propagate through contact, be that electrical adjacency or social contact, and they both spread much faster through certain individuals, so-called super spreaders, to use a term we're currently a little too familiar with. Following this logic, I used a biological model known as epidemic control analysis and applied it to an electrical cascade in a transmission network. The model searches for the super spreaders in a network by repeatedly simulating the transmission of a virus when different individuals are no longer in the susceptible population, something which can be achieved through isolation or immunization. When applied to a power network, the fault current is the virus, the transmission lines are the susceptible individuals, and the electrical adjacency between those lines is the contacts. The model then simulates the cascade with different transmission lines isolated and selects the transmission line whose isolation best protects the remainder of the network. This information is then stored in a lookup table, and the process is repeated for all sets of triggering individuals. Then if a set of triggering individuals fail, the lookup table is consulted and a transmission line is selected for isolation. This redirects the fault current to a more stable part of the network and reduces the impact for consumers. Using this method has yielded very promising results, particularly on larger networks of more than 1,000 transmission lines, where the impact can be reduced by up to 50%. The next step is to test this on a real-time simulated network with hardware in the loop to represent a real-world implementation of this method. Using this approach, it should be possible to significantly reduce the impact of a cascade once it has started. Thank you.
Thank you, Chris. Again, very interesting. Thank you very much for sharing with us this afternoon as it is now. Okay, so we've had three-minute presentations, and we're going to move on, obviously, now to our fourth. So we'll say a welcome to Sobin, Sabu, Thankachan. Hope I might have got your name right there. Forgive me if I haven't. Yes. Would you just quickly, whilst we're loading your presentation, like to say hello and say where you are?
Hi, my name is Sobin Sabu Thankachan. I'm at the anthropology department, and I'm from India. I'm currently here at Durham, and my topic is socio-technical perspective for rural clean energy projects.
So namaste. When you're ready, are you ready to go?
Yes.
Good. So you have 3 minutes then, starting now. Best of luck.
Thank you. We humans invent new technologies to make our lives easier. But have you ever thought that some of these technologies make our lives difficult? Why do these technologies have some unintended social consequences? Well, society and technology influence each other. The socio-technical systems perspective is a concept that shows how society and technology develop in mutual interactions and how they co-evolve together. Here, I would like to concentrate on clean energy technologies and how these technologies can cause unintended social consequences. For this purpose, I would like to take a case study of a solar park in Kerala, which is a southern state in India, the place where I'm coming from. In 2016, the national and state government planned to implement a 200 megawatt solar park in Kerala. It was technically and economically analyzed However, the potential social impact of this project was neglected. For the construction of this project, indigenous people were evicted from their lands. Large infrastructure and the fences around them forced the villagers to walk longer distances for basic needs like to collect water or to take part in social activities. There were no area left for further developments like the construction of schools, community halls, etc. All this led to strong social resistance against the project, leading to the scaling down of this project from 200 megawatt to 50 megawatt. And this is just one of the many examples where social context is neglected. As you can see in the slide, the left-hand side shows the expectation or the ideal scenario where the technical feasibility, economic analysis, and social impact are considered as equally important part of a puzzle. However, in reality, as you can see on the right-hand side, the engineering and financial aspects are given utmost importance and the social context is ignored. As a result, the overall project fails. Social technical perspective actually encourages the transdisciplinary approach where engineers, economists, social scientists, and even stakeholders work together to develop and design the projects. Research focuses on how socio-technical perspective can be used in the post-pandemic world to achieve sustainable and successful clean energy projects. The pandemic has affected the social and economic aspects and conditions of low-income population globally. So a transdisciplinary approach is essential to achieve socially inclusive energy transition. Therefore, I believe that my research would enable clean energy technologies to achieve its true purpose, which is simply to make the lives of people easier. Thank you.
Thank you. That's a very nice landing point. Thank you very much indeed. Good. So we're going to move on now then to our fifth presenter, Supatra Manin. Supatra is there. Good morning. Good afternoon. Would you like to just introduce yourself whilst we're setting up the slide, Supatra, and then we'll get you going.
Okay, great, thank you. I'm Supatra Manin. I'm studying at the University of Greenwich in the School of Science on anaerobic digestion of seaweed, which I'll go on to explain a bit more.
Well, welcome. Thanks very much for being with us this afternoon. We've got the slide up there then, Supatra. As soon as you're ready, best of luck.
Oh, thank you very much. Have you ever been ready for the beach, excited to dip your toes into that nice, cool water, only to find them met by seaweed? Imagine if we could collect that seaweed and use it to fuel your cars or heat your homes instead of burning fossil fuels for that energy. Energy generation using fossil fuels, as we know, create carbon dioxide that is a major contributor to climate change. Just from heating your homes and cooking your food, an average UK person produces about 1 ton of carbon dioxide per year. The UK population is around 67 million. That is a lot of carbon dioxide. So, what if we could use seaweed that takes up this carbon dioxide and use it to produce renewable energy? That is exactly what I'm trying to do through the process of anaerobic digestion. Now, we can liken anaerobic digestion to a mechanical gut. You put food in, it gets digested, and then some gas is produced. In this instance, most of that gas is in the form of methane, which we can use as a fuel for energy. So we can think of the mechanical gut like a gas-producing factory filling up balloons. It consists of a production line with different groups of microorganisms working together to produce this gas. When we put seaweed into the production line, hydrolytic bacteria break it down in a process known as hydrolysis. Then other microorganisms use these broken down parts to produce the methane gas. So hypothetically, with seaweed, we would expect, for example, around 10 balloons to be filled up. But in reality, only about 2 are filled up. So you can see this isn't a very economical use of the seaweed. So one of the possible reasons is that seaweed could contain potential inhibitors or poisons that could disrupt this production line. One, I am trying to find out if whether these poisons or inhibitors exist, and if they do, what are they, and how can they be removed? So I treat the seaweed in different ways and I put it back into the production line. What I found was that by removing potential inhibitors, or known as polyphenols, we can make more methane and thereby fill more balloons. So ultimately, we're on the road to seaweed being less of an inconvenience every time we go to the beach, and instead becoming a sustainable source of fuel for the future. Thank you.
Thank you. Thanks very much, Subhadra. Great, really interesting as well. Thank you so much for being with us.
Thank you.
So we've got one more presenter this afternoon, which is Georgina Hatch. Just see if you're there. Yeah, I can see you there. Georgina, you just, if you'd be kind enough just to introduce yourself whilst we're getting your slide up.
Yes, I'm Georgina. I'm at Durham University doing a Master's in Sustainability, Energy and Development, and I'm from North Yorkshire.
Great, nice to meet you. We'll just get your slide up. There we go. I think Lynn's got it up. Can you see that there?
Yes, I can.
So as soon as you're ready then, Georgina, I'll let you get going and wish you best of luck.
Great, thank you. So renewable energy is the future, right? It's going to reduce carbon emissions and provide a safe source of energy indefinitely. By definition, it's renewable and limitless, and it is, except we're limiting it by forcing it into a fossil fuel network, by treating wind and solar power like they were coal or oil. We're dealing with a completely new type of energy source, so why are we managing it in the same old way? To avoid energy crises such as power cuts or blackouts, like we've seen in California and Texas most recently with their freeze, we need to rewrite the rules of the network. So the focus of my thesis is the prospects of virtual power plants and their role in avoiding energy crises. So virtual power plants are a cloud-based power plant. They connect a network of sources such as wind farms, biomass boilers, residential solar panels, as well as energy storage, and that can be personal energy storage or hydrogen fuel cells or battery fields. And they take all these different sources to give one graph of the total energy available at any point in storage and in generation. So that's something a traditional power plant just can't do. As well as this, they also predict energy generation, which is much harder than as we would in the past say, well, we've got 10 tons of coal in storage that we can burn. Because with renewable energy, the source quite often isn't tangible. So a virtual power plant has to assess weather patterns seasonally and the day before to look at wind speed, UV levels, rainfall, direction, to know how much generation is going to be possible. And this total summary provides the flexibility, which is the key to negotiating peak energy demand that we see at evenings and weekends, and especially with the increase of electric vehicle charging, that's going to be a huge drag too. So currently there's 4 virtual power plants being developed in the UK. And so far, most research is focused on the technical optimizations of the power plants. I'm looking at how they can defend against an energy crisis. So because of the fluctuating nature of renewable energy sources, such as solar power, it's only available during the daytime. Wind is only available when it's windy. We need a range of sources. So for example, in the 1970s, there was a 3-day week power shortage. I don't know if any of you remember that, but that arose because of almost a total reliance on one source, which was coal. When it was unavailable, there wasn't enough power. And you might assume we wouldn't have this issue with renewables, but in Zambia, a country that uses 95% renewables, it's almost exclusively hydropower, and it's based at 3 main sites. So they're treating water and rainfall as if it were a fossil fuel in the same type of network. Then one year they had a drought and the reservoirs depleted and nationwide blackouts became standard practice for 2 years. And climate events like this are becoming increasingly common. The same situation is possible with any source. In the UK, we're starting to see huge wind farms created, which is great, but still one huge centralised source is a huge weakness for the network. So I want to prove that a range of electricity sources is essential, and a virtual power plant is the key to creating and managing the grid flexibility for that.
Thank you very much, Georgina. Excellent. You certainly reminded some of the older members of the audience, Simon, Paul and myself, of the 3-day week. I certainly do recall all of that. Thank you very much for an excellent presentation as well.
Thank you.
So, Lynn, I think it remains really for me just to sum up and say what will happen next. Correct me if I'm wrong. If that's right, and do come in at any point. Yeah, I see Barbara putting in as well. You're bringing back a lot of memories there for some of us, Georgina, including being stuck in lifts, I remember. I love this 3-minute competition, particularly as a panel chair. My notes tell me it comes from the University of Queensland, so I want to sort of research the history of it. I'd much less rather be a judge because, I mean, it sounds like a cliche, but it is going to be very, very difficult, I think, for our judges to decide among 6 excellent presentations, but that is their job. And I'm sure it's something they're going to really look forward to. There'll be some excellent conversations. I've got Adrian, Sarah and Chris on my screen next to one another there this afternoon. And it will take a bit of time, which is why we won't be getting the results back until 4:15. Barbara's just come in there to talk about being really miffed. But you won't be at 4:15, Barbara, because you'll be opening the envelope. And you'll be able to say how we've got on. We're getting more comments in now about what happened in the 1970s. Some of you might know the great historian E.P. Thompson, Making of the English Working Class. I know that Adrian certainly will. I remember reading a book by E.P. Thompson around 1980 called Writing by Candlelight, which was a brilliant discussion of the way that the middle classes reacted to the blackouts in the 1970s. Dear Sir, Writing by Candlelight, a book that I would heartily recommend to anybody. Is there anything else right now, Lynn, that I should be doing, or that anybody should be saying, or are you all about to go to a virtual lunch?
I think it's time for a break. We will reconvene for our keynote speech at 2 o'clock, which John will be introducing. And I'm going to put yourself and the other panelists now into a breakout room where we can deliberate on the outcome. And we will pass that to Barbara, because Barbara's going to do the presentation of the awards later on when she does the overall conclusion to the conference.
So big thank you to everyone. Sarah, you got your hand up there? Oh, it was a clap handy, is it?
I clapped.
Yeah.
Because it was wonderful.
Excellent. Yeah, it was wonderful. Thanks to the 6 presenters. Really brilliant. You all did incredibly well. Keeping to fit, I can't imagine having to do it, but it was really well done. So we're going to a breakout room now, some of us, and I'll be interested to get the thoughts of the judges. And stay well, everybody. Stay safe. Take care. Bye bye.